Good morning, students. This is lesson 6-5, part 1. If you have your book with you, it is page 416. So let's go ahead and get started. All right. So today's lesson is on linear inequalities. Now, what a linear inequality is, basically like you made a linear equation and turned it into a line on a graph, a linear inequality is basically a linear non-equation that becomes a line or a borderline on a graph, okay? And it's on page 416 in your textbook. So first, I want to do a quick review of inequalities, what you had learned before, so that it's kind of refresh it in your memory now, okay? An equation tells you what x is, or whatever your variable is. An inequality tells you what x is not, okay? So if I had an equation x equals 5, or an inequality x is greater than 5, then it tells you some information about what x is not what x is. There are open inequalities, which usually have an open dot when you graph them as a number line, and that is greater than or less than. There are closed inequalities, which are greater than or equal to, less than or equal to. And they have a closed dot when you put them on a number line. Inequalities are read from left to right, meaning that whatever is on the left side is, whatever the inequality is facing on the left side, that's how you say it. So on the left of the inequality would be greater than what's on the right in this case. What's on the left of this inequality is less than what's on the right. When a negative is multiplied or divided to both sides, and I'm going to circle these terms, multiplied and divided, the direction switches of the inequality. So for example, if you had this and you multiplied or divided to both sides, then you would change it to this, okay? Now, other than that, inequalities work pretty much the same as equations do, okay? You use isolate, opposite, and both to solve inequalities. If there's two-step inequalities, you do addition, subtraction first, multiplication and division second. One thing I want to say, if you are adding or subtracting a negative to both sides of your inequality, it does not change the sign, only if you multiply or divide. Just keep in mind, if you have a negative on one side and you move it to the other, you move it by addition, so it actually adds to it, not subtracts from it, okay? Because you move them by opposite operations. So if something's negative, it becomes positive when you put it to the other side. However, when you multiply or divide by a negative, they stay negative and it switches the inequality. All right. Hopefully that helps. If you need more review, then you can pause the video now and then go back and look in one of the previous videos or previous chapters. Okay? Now, let's talk about linear inequalities. A linear inequality is graphed on a coordinate plane just like a linear equation. Now, sorry, my cat keeps jumping up here. She wants to be in the video. Continuing on, trying not to get interrupted here. Really? This is just one of those days. Okay, calm down, Kanga. All right, so linear inequalities are graphed on a coordinate plane just like a linear equation. Okay, now normally when you graph a you have let me pause for a second. Okay, I'm back. Now, normally when you graph an inequality, you do it on a number line, but with a linear inequality, you graph it just like you graph a linear equation, okay? A couple things that are different. I have some vocabulary to go over. The word border. A linear inequality line is considered the border between the half of the plane that is true and the half of the plane that is false. So on your coordinate plane, you actually cut your coordinate plane in half. And generally speaking, one side of it, if you put in any points there and put that into the equation, those points will make the equation true, or the inequality true. If you put the coordinates of a point into it and you get a false statement, then that would mean it's going to be the other side of the line, okay? Now, if you have an open inequality, you would have an open line or a dashed line here to show that your inequality is open. If it's a closed inequality, then of course you have a closed line, okay? Let me go over the steps and then we'll go ahead and do a couple of problems here. So the steps are to write the inequality as an equation to get a line on the coordinate plane. Now, we put the line on the coordinate plane the same way that you learned how to do it when you are just putting a line on there, like in a linear equation. That was the word I was looking for. So you can use the slope and the y-intercept to get a point, and you can use a table of values to get several points, and then just draw the line. Step 2, make the line open or closed depending on the inequality. So basically, make sure that you put the correct style of line. Number 3, use a test point not on the line to see if it is true or false in the equation. Now the test point that I recommend is the point 0, 0. Why? Because it's easy to remember and easy to find, okay? And that is the center of your coordinate plane. Hint, but you will have to use another point of 0, 0s on the line. Now, using a test point, you cannot use a point that is on the line. You can use any point that's anywhere else on the coordinate plane, but not on the line. And number 4, if it is true, shade the side of the line. If it is false, then shade the other side, okay? So let me see how a linear inequality is the same as a linear equation. With a linear equation, it's the same in that you get a table of values and then put a point down, and then yeah, it's actually fairly simple. How it's different is you can either use a dashed or a dotted line. A dashed or a straight line, and you have to shade the side of the coordinate plane that makes it true. Oops, I forgot I went to problem 2. I forgot to do problem 1 with you first. Okay, so problem 1, I have an inequality here. It's written in slope-intercept form. Y is greater than x minus 3. And I have a couple of points. So which point is true? So I have the point 1, 2, and negative 3, negative 7. So what I'm going to do is I'm going to substitute in these points. So here's the point 1, negative 2. So I have 1 positive 2, and then I have 1 is my x value, 2 is my y value. Now I'll go ahead and simplify. 1 minus 3 would be negative 2. So is 2 greater than negative 2? Yes, that is true. So that statement is true. Now I have another point here, negative 3, negative 7. So let's go ahead and put that in. Okay, so I have y is greater than x minus 3. I substituted a negative 7 for y. -3 for x. So now I have the statement -7 is greater than -3 minus 3. So -3 minus 3 is -6. Now, I want to remind you with negatives, the value of greater or less than is opposite than when they're positives. So is -7 greater than -6? No, that would be false. Okay, so we'll cross out that one and check mark that one. Okay, so um, the reason here is when you put a point into the equation, it's either going to make a true statement or a false statement. Now, if I was graphing this, I would shade in the side that had the true statement. Now, let's go to problem 2. So problem 2 says to graph y is greater than x minus 2. Okay, so I'm going to start with writing it as an equation. Now, this is just so that I can find the line, because that would be the equation for the line. Now, it's in slope-intercept form, so I know that my beginning value would be -2, okay, for the y-intercept. So go 1, 2. So that's my beginning point. Since there's no coefficient to x and the coefficient would be 1, so my slope would be 1 over 1. So my line would go 1 up, 1 over for the next point, 1 up, 1 over for the next point, 1 up, 1 over for the next point, 1 up, 1 over. Okay, so now I've got some points to make the line. Okay. Now let's take the second step. I want to look at my inequality when I make the line. Is it an open inequality or closed? This is my wife's pen, so in case you're wondering. So it is definitely an open inequality. So I make a dashed line. Okay. Now, the third step is I want to do a test point. Now, I recommend it using the point 0, 0. So, in my original inequality, I'm going to substitute 0 for y and 0 for x. And I'll see if the statement is true. So go ahead and solve. 0 minus 2 is -2. So now I have the inequality statement 0 is greater than -2. Now I boxed it because that is true. Okay, so since that is true, then the side of my inequality that has 0, 0 on it would be graphed. Or I'm sorry, would be shaded. So let's take a look. 0, 0 is the center point of the coordinate plane. Now I do want to say something here. If my line goes through 0, 0, then I cannot use 0, 0. I'd have to use another point. Now, what point should I use? I said 0, 0 because it's like easy to remember, but you can use any point anywhere on the graph to determine this. Okay, so since that's true, I shade the side that contains that answer. Okay, now you can use a highlighter, you can just use a pencil and shade it, whatever it is that you prefer. Okay, again, markers and highlighters do have a tendency to run out of ink if you use a lot of it, like I just did. All right, so now let's do problem 3. By the way, these are the same problems that are in the book, so it should be fairly easy for you to review this. One variable inequalities. Sometimes you're going to have an inequality or an equation that only has one variable, like x is greater than -1 or y is greater than or equal to 2. Okay? In a case like that, the way that they are graphed is simply by making a horizontal or vertical line. Okay, so in this case, x is greater than -1. So I go to -1 on my x-axis, and that is my starting point. Okay, since there's no y value, then what I am going to do is I just am going to make a line um, that is vertical to represent my graph. Since this is an open inequality, I'll use an open line or a dashed line. Okay, now I just have to take a look at my inequality. So x is greater than -1. Now, since I'm thinking linear now, that would imply that anything that's larger than -1 would be x. But what I'm going to do, um, hold on, I'm just going to double check, make sure I'm doing this right. Yep. So since x is greater than -1, then I want to shade everything that's on the greater side of -1. Now the idea for me here, since I only have one variable, then I don't have to put in a test point because I don't have a y value, I only have an x value. Okay, so then I could read this more like a number line, and I'm just focused on what the x line is. The y line is almost like a technicality. I can almost ignore it. Okay, now let's go ahead and do the inequality here for y is greater than or equal to 2. So pretending that it is just an equation, then I would just go to 2 as my point. Then I would make a line horizontally. Now you notice I made a solid line here because I have a closed inequality. Okay, so closed inequality means closed line. Now the question is stating that y is greater than 2, so the value of y, or whatever y represents, would have to be above. So I would shade everything above that line. Okay? All right, I hope that helps. Thank you much, and talk to you later.